Okay, welcome students. Today we are going to discuss a new chapter that is gravitation. Okay, so it will be the first day, first class, and it will be the introduction class only, or if possible, I'll go to discuss up to the point gravitational force. Okay, so here subject name is physics. We are discussing for foundation. Today's introduction class basically. So as you know, my name is Amarnath. Okay. So let us start. First of all, we'll discuss the definition of gravitation. What is gravitational force? Okay, all the things will be discussed. Newton's law of gravitation also will be discussed. Okay. So first, what are the actually chapter contents? Okay. We are going to discuss in these chapters. Okay. These are some points actually. Altogether, we are having about 9 points. Okay. Uh, almost 1.1 day like that. Okay. So first we are going to discuss gravitational force. Okay. You can write these also. Okay. The topics we are going to discuss. Remember, this topic is that the set of topics are exactly same as that of 11 also. Okay. Remember, for that IIT they need examinations. Okay. In the same sequence we will be discussing, but we are discussing very that one. Okay. We'll discuss here the basics only. Okay. So that is first point is gravitational force. What is gravitational force? We will understand. Okay. Newton's law we'll discuss. The second point, gravitational field. Okay. And one more thing you should understand that gravitational force, electrostatic force, both are actually lot of things are similar. Okay. If you understand the gravitation chapter, then electrostatic chapter also will be easier for us. Okay. So that is very important. So you have to put your 100% concentration uh, for this. Okay. Then third point, we are going to discuss acceleration due to gravity. Okay. Acceleration due to gravity at different height. Acceleration will be different. Even at different point on Earth also acceleration due to gravity will be different. Normal value we are taking acceleration due to gravity z value 10 only, but it is actually varies place to place. Okay. Then we discuss gravitational potential. Okay, this part will be a little bit new for you. Okay. Oh, no need to worry. We will discuss all these things. Then gravitational energy. Okay. So what will be the energy between two planets? What will be the energy between a particle above the surface of Earth? All the things. Okay. These are the points. Then we will discuss escape velocity. Okay. At what speed I should throw a particle from the surface of Earth so that it goes out of the space. Okay. So that is also. Then we'll discuss orbital velocity. Okay. Say moon is revolving about the earth. Okay. So what should be the velocity of the moon? What should be? Okay. Or say artificial satellite. India is launching an artificial satellite. So what should be the speed of the artificial satellite? Okay. And you know that that is NASA's Space Center. That is also artificial satellite only, na? So recently that Shubham Shukla came back from that, na? So the Indian astronaut. So that is also a satellite only, na? So revolving about Earth. Okay. Then we'll discuss energy of a satellite. Okay. Okay. The ninth point is Kepler's law. Okay. Kepler's laws. We have three laws: law of orbit, law of area, and law of time period. Okay. We'll discuss all these things. Then finally we'll have that one chapter test. Okay. So with this sequence only we are going to discuss. Well, so at the very beginning, what I'm going to discuss today, gravitation and what is gravitational force. Okay. So it will be the today's discussion. And I hope you have copied all these things. Can I go to can I rub all these things?
Yes,
Yes,
sir.
sir.
Okay. You write all these points. Okay. We are going to discuss. You will have an advanced
Yes.
picture actually. what we are going to discuss. So let me discuss what is gravitation. Okay. Actually, you see, in space, any two particles attract each other. Okay, I have already discussed in the first chapter little bit about the gravitation also. You remember, I think. Okay, in space, any two particles attract each other. Say this is moon, this is Earth. Earth is attracting moon. Say sun and Earth is attracted by the sun. Okay, even that one say this is one a marker. Okay, pencil. Okay, this one is a pencil. This one, these are they are also attracting electrons, but gravitational force is very less, so it's not actually visibly seen here. And one more thing, if they are in space, they will definitely attract each other. Okay, they will collide. But here actually we have lot of particles around it, so other particles are also attracting it. So net force on it becomes zero. Okay, but it is fact that any particle having mass in space attract each other. Okay. In electrostatics, you can find like charges repel, unlike charges attract. But gravitational force always attractive. Any two particles, if they are having mass, definitely they will have mass, okay, and they will attract each other, okay. And that attraction force is called gravitational force. You please write down the property by which two particles having mass attract each other is called gravitation, and the force is called gravitational force. Okay. Now we will discuss some characteristic of this gravitational force. Okay. And remember, these will be little bit similar to electrostatic force also. The force between two charges is called electrostatic force. Force between two mass is called gravitational force. Okay. So electrostatic forces also have some character. So exactly that way, magnetic force also will have some, gravitational force also will have some character. Okay. So you please keep on writing all these things. Definition: the property by which two particles having mass attract each other is called gravitation, and the force is called gravitational force. So let us discuss the some properties of gravitational force or characteristics of gravitational force. Okay. So first character is they are always actually attractive force. Okay. Gravitational force cannot be repulsive. Remember, I may ask you some quiz, okay? Depending upon the information I am giving you. Okay? So you each and every line of that chapter is very important, okay? And if something is hidden between two lines, that is also important. You will try to understand. Say, I'm not saying about the electrostat here, okay? So you have to compare it. Gravitational force is always attractive, but electrostatic force may be attractive also, may be repulsive also. Okay? So these are some difference also. Then second point is it is a conservative force. Okay, you please first learn this term. Okay, conservative force. Okay, say this is the that one I can say this is the Earth. Okay, so say this is one particle. I have taken this particle to this position, then I have taken back, and finally say coming to this position only. Okay, through this loop. Okay, particle initial position and the final position is same. So work done will be zero. If it is so, if work done is zero in a particular loop, then the force is called conservative force. Okay, gravitational force is a conservative force, but friction is not a conservative force. Okay, friction, say this is a rough surface. Okay, this is a rough surface. If you drag a particle along this path and come back to this, okay, so the net work done by friction is not zero here, though the displacement is zero. Okay, so it means friction is non-conservative or gravitational force is conservative. Okay, so you remember the word conservative because work done in a closed loop is zero, since work done in a closed loop is a closed path, you can say, is always 0. I can ask you the definition of conservative force also. The force is called conservative if the work done in a closed path is always 0. That is called conservative. I can ask you non-conservative force also. If not 0, okay, that is non-conservative. Friction is the example I told you. Well, so the next point is what? It is a central force. Central force means what? Actually, say this is a particle, okay? Say this is M1, okay? And say this is M2. So M2 will attract M1 along this line, and M1 also will attract M2 along this line only, okay? Means they will not attract along this in other some directions, okay? They always act along the line joining their center of mass, okay? The two particles always act the force on each other along the line joining the center of mass. If it is so, it is called central force. Central force means they are along the line joining the centers. Force is along the line joining the that is the definition of central force. Next is it is a force of two particle system, okay? And remember, all these are valid for electrostatic force also, okay? Electrostatic force also a conservative force. Electrostatic force is also a central force. And electrostatic force is also a two particle system force. So what does it mean? You see, say this one is a particle, okay? Say this one is a particle. Say it is M1. And M1 is giving a force M2. Say this is, sorry, the force will be always attractive, na? So say M1 is giving a force, say it is 10 Newton, say 10 Newton, okay? So if I place any M3 here, then also force between M1 and M2 will be remaining same only, okay? Means due to the presence of M3, the force between M1 and M2 does not change, okay? But M3 cannot disturb the force between M1 and M2. That is different issue. That force on M2, net force on M2 will be changed because M1 also attract it and M3 also will attract, na? So net force will be the vector resultant only. Okay, we'll discuss all these things. But force between M1 and M2 does not depend upon the presence of any third mass. Okay, so it means force between any two mass. Okay, force between any two particles does not depend on the presence of any third particle. Okay, say the force between two masses 10 Newton. Yeah, जो भी हो, whatever it may be. So it will always be remain 10 Newton only between them, between them. If you place some other mass also, then also net, but the force between them will be same. But net force will be changed because this will also attract, this will also attract. So net force will be, say this particle is attracted by this, okay, by F1. and some other particle is attracting by the F2. So the resultant will be like this, okay? This is the resultant force. That is different. But value of force between two particles always remains same. Next point is that is actually it is the weakest force in the nature. Actually, in the nature, we have four forces, okay? In the nature, we have four forces. We have four forces. The strongest one is called strongest nuclear force. Strongest nuclear force. That is the strongest force, but the name only suggests, na? Say force between two neutrons, force between two protons, okay? After that, it comes weak nuclear force. These are some naturally existing force, okay? Weak nuclear force. Then it comes electromagnetic force, force between two charges, force between two magnet like this, okay? Electromagnetic force. And at the last, that force comes gravitational force, okay? So gravitational force is the weakest force. Okay, Sikha, tell me, what's the question?
Yes, sir. I have a doubt actually on atom. That, as you know, that in the nucleus protons are there as well as electrons and neutrons. So I have like the question that why do protons and electrons don't attract each other, as proton is positive and electron is negative. So as we have also learned that in like magnet that opposite poles attract each other. So why isn't it happening in atoms, sir?
So actually, you see, that elect that is also called the range of force. Okay, range of force. We are going to discuss in the 6th point. Okay, actually, you see, the gravitational force, na, say it is the longest. If a particle is here, say this is the Earth, and another planet is there billion miles away, billion light years away. This force, this mass also can exert a force on that, okay? Because gravitational force is a very long range force, okay? Electrostatic force is not a long range force, remember. Say two protons will repel, okay? We understand that two like charges will repel. Say this is proton, this is proton. So they should repel each other. But remember, it is not actually that one. It does not valid for any short range that one distances. If you bring two protons, if you bring two protons to a separation of very small separation, that is say 10 to the power minus 15 meter, 10 to the power minus 12 meter, means very close. It is the size of a nucleus, okay? Then remember that two proton will not repel each other. They will start attracting only, okay? That is called nuclear force. It means electrostatic force will be not valid when
क्या
the
क्या अपन यही पापा.
electrostatic force will not be valid when the two charged particles are very close separation, like 10 to the power minus 15 meter, 10 to the power minus 14 meter, 10 to the power minus 13, 10 to the power minus 12. Means if it is in the size of atom, size of nucleus, okay, better to say size of nucleus. 10 to the power minus 15 meter is the base example, okay. Then two charged particles will not repel even they are opposite charge. Even at the separation, a proton and a neutron. Neutron is chargeless. So proton and neutron also will attract only. Okay. Proton and proton also will attract. Proton and neutron also will attract. Well, so that is called nuclear force. It means electrostatic force is not valid where if the separation is, or if the size of the domain is less than 10 to the power minus 15 meter, or it is very less, okay, we can say. So that is why
Got it.
we have to take four forces, na? Four forces. Because one is invalid at this domain, other is invalid at this domain, na? That is why. Okay. These are the, and remember, if you ask me why two protons repel, I don't have any answer. If you ask me why two masses attract, sorry, can you explain why two masses attract, why two masses do not repel each other? If you ask me, I don't know, because it is completely experimental and research is going on. Okay, lot of work to in future. Hopefully, you can also contribute on that part. Okay, but remember, once you proved why two masses attract, we know that two masses attract, but why? We know that positive charge repel, but we don't know why. This is experimental. If you can prove it, or if you can get any linkage between mass and charge like this, like that, okay. Remember, you are going to get the Nobel Prize. Okay, this is waiting for you only. If you can, because a lot of work is to be done. Okay, it's still left actually. That is the thing. So you should have the dream of doing good work on that. Okay. So this is the weakest force. That is the subse dubla force. Okay, weakest. Strongest is the nuclear force. Okay, it is the longest range force. Longest range force. That one. It means it can take place up to very, and nuclear force is the shortest. Remember, nuclear force is the it valid up to 10 to the minus 15 meter only. 10 to the minus 15 meter is very less than the size of a nucleus. Okay, but gravitational force is the longest. Longest means longest, enough. What is enough? Okay, let us discuss Newton's law of gravitation. So this one is a particle. Okay, particle means size is small. Okay, then only I can measure distance. Na? So this is a particle M1, this is a particle M2. Okay, so I can say that this is the separation between them. But if we take a bulk object, so how, from where I will discuss the distance. Na? So that is why what we take, I take only a single particle. Particle means size is very small. Say this one is M1, this one is M2, and this one is the separation between them. Okay. So what is Newton's law of motion? So it is please write down the force of attraction between two particles in space is directly proportional to the either mass. Means it is directly proportional to M1 also, M2 also. And inversely, directly proportional means if one goes high, other also will go high. Inversely means if one goes high, other will go down. Okay. And inversely, proportional to the square of the separation between them. Okay. It means force is directly proportional to M1 also, directly proportional to M2 also, inversely proportional to 1 by R square. So it means if you bring all them closer, so it will be directly proportional to M1, M2 by R square. Okay. So if you equate it, if you put the equation sign, and you already know that there will be a constant of, it will be what? M1, M2 by R square. Okay. So this is called universal gravitational equation. Z M1 M2 by R square, where this is capital G, huh? Is a proportionality constant called universal gravitational constant. And remember, it has a value, fixed value also. You can learn it, okay? 6.6 into 10 to the power minus 12, okay? And SI unit will be Newton meter square by actually kg square, okay? You please try to know that one also, okay? Value of universal gravitational constant as well as that unit also, okay? You should remember this. If you go to more closer, you can say that it is actually 6.67, okay? It will give you a more closer value, 6.67. And remember, unit also important, Actually, unit can be found out from this only. You see, Z equal to what? Z will be FR square by M into M only, na? So F means Newton, R means meter square, M means kg, okay? From this also you can understand the unit. This tree is called universal gravitational law. Yeah, universal law of gravitation. And this is the equation, okay? Please copy it. Let me know if it is copied. I am going to give you some numerical, okay? We are now in a position of doing numericals. So before doing numericals, I am going to give you a formula, okay? You please uh, understand this formula, okay? Just you remember this formula. I'll give you the physical meaning of the formula, and but you remember, learn it, okay? You should learn it. Say a particle is given by two vector. Okay, say this force is a vector, I know na. Say this is a vector F1 and this is another vector F2. Okay. From the triangular law of vector addition or parallelogram law of vector addition, we'll understand that if the two particles are pulled by F1 and resultant will be along this direction somewhere, okay? And the resultant force is always given by this formula, okay? Please remember this formula, please. F1 square means that F1's value, say it is 3 Newton, plus F2 square means F2's value, say F2 is 5 Newton, it means 5 square, okay? 3 square plus 5 square plus 2 into, normal 2 into, F1 means again F1's value into F2 into cos theta, okay? We have already discussed in trigonometry, okay, cos theta. So what is theta? Theta is the angle between the two original vectors. Okay. Say F1 and F2. I have given angle 60 degree. So here it will be 60 degree. Okay. So you please remember this formula. Formula for resultant vector. Okay. Yeah, you can say that resultant force. Because at later course of time, it will be required for doing problem. Formula for resultant. Vector. I'm writing just vector, okay? It may be a force also, okay? You please write this also in a separate box, okay? Good. What is theta here? Theta is the angle between the two vectors, okay? What is F1? First vector's value. Remember, huh? If the first vector is -5, then also you'll put 5 only, okay? Not -5. Because this is magnitude only, okay? Value. 5 square, 3 square, okay? Like that. Okay. Please let me know once you copied it, okay? Okay. Now let us try some numericals, okay? So this is a question, okay? Force between two particles of mass 2 kg and 8 kg at a separation of 4 meter in space is, okay? You do not require to put the value of z, okay? The answer is in terms of z only here. So please try to solve this question, okay, using your that formula, okay? I have already given you. Okay. Okay, very good. Correct. No. Check it once more. The question is force between two particles of mass 2 kg and 8 kg at a separation of 4 meter in space is, okay? We know that F equal to what? Z m1 m2 by r square. Here one is 2 kg, another is 8 kg. All are in SI, so no need to worry. So F will be what? Z, you put Z only, no issue. M1 is 2, M2 is 8, and it is 4 square, okay? So it is Z, it is 16, it is also 16, it has been Z, okay? So F equal to Z Newton, okay? All are in SI, so you can put directly Newton. So this is the answer. The answer is A correct, okay? Hmm. Good. So please solve another question. In the x-axis, three particles of masses 2 kg each are placed at x equal to 0, x equal to 2 meter, x equal to 4 meter. Find the net gravitational force on the particle at x equal to 0. Okay. So please you try once. Okay. Let me try. Say this is my number line. Okay. Say this is at x equal to 0. So at x equal to 0, 2 kg is there. Okay. 2 kg. And at x equal to 2, say this is x equal to 2. So here also it is a 2 kg, okay? And at x equal to 4, so here is also a 2 kg, okay? But now I need to find out the net gravitational force on the particle at x equal to 0, okay? So you see, so first of all, that this 2 kg will apply a force, this is F1, okay? So it will be pulling force only. And this 2 kg also will attract, na? So this also will be in the same direction only. This is F2, okay? F1 and F2 are in the same direction, okay? So the resultant force will be simply F1 plus F2 only, okay? Because they are in the same direction. Even mathematically also we can prove it from that formula. From that formula, we understand that you see it is f1 square plus it is f2 square plus it is 2 f1 f2 and cos 0 degree. Okay. So it will be what? It will be f1 square, it will be f2 square, and cos 0 value is 1. So it will be 2 f1 f2 only. And it will be what? It is a square plus b square plus 2ab. So a square plus b square plus 2ab. Always what? A plus b whole square. So it means it is f1 plus f2 whole square. Now whole square and square root will get cancelled. Na? So it will be f1 plus f2 only. Okay. So do you see that directly also we can understand with the feeling. Na? They are in the same direction. So they will be attracted. So sorry, they will be just added only. So it will be f1 plus f2 only. Okay. But if you go with the proper that one, okay, vector law, I have already discussed in the previous year. You can also find the same answer. Okay. Now, so F1 is what? F1 is the force between 2 kg and this 2 kg. Okay. The formula will be G into 2 into 2 by 4 square because separation is 4. Now F2 is what? Force between 2 kg and this 2 kg. Okay. So formula will be G into 2 into 2 by, but this time separation is only 2, na? This much only. So it will be 2 square. Okay. So what is common here? You say 4Z common. Okay. 4Z common. You can take 4Z out. 4Z out. So what is left? 1 by 16 and 1 by 4 is left. Okay. So it will be 4Z. You can take LCM. It will be 1 plus 4. So it will be what? And 4Z. So 5 by 16. Huh? So answer is what? Answer is 5 upon 4 into Z is the answer. Okay. So it will be the net force. Check the calculation part once more. Huh? 4 is 16. Huh? So A is wrong, B is wrong, C is wrong. So D is correct. Okay. Good. This will be the answer. Okay. This will be the force on x equal to 0. Okay. So let us try a similar question. Okay. Please try it. I have changed the coordinate actually. What? 2, 2. X equal to 2 I have given. But I need to find the net gravitational force on the particle at x equal to 2. Okay. Here, if I draw again the situation, so say this point, okay. So at x equal to 0, we have 2 kg. So this is x equal to 2, okay. Okay. So here also we have 2 kg. So this is x equal to 4. It is also 2 kg. But now actually our that one concerned particle is at x equal to 2. It will be at x equal to 2 only. Okay. So that this 2 kg will attract it in this direction, and that other 2 kg will attract it in the opposite direction. Okay. One will attract in this direction, other will attract in this direction. Say this is F1, this is F2. Okay. They are in opposite direction. You can say that they are at 180 degree. Okay. So if I go with the trigonometry, directly I know that they will just repel, sorry, it will be cancelled out of there. Okay. So it will be what? F equal to F1 minus F2 only. But still, if you ask me, sir, why minus only? Okay, I'll explain. So what is F1? F1 is nothing but Z into 2 into 2. Okay, 2 into 2 by separation is also 2 only. 4 minus 2 is 2 only. 2 is square. Minus F2. F2 is what? Z into that 2 kg into 2 kg. Okay, 2 into 2 By here also separation only 2, no? That is 2 minus 0 is 2 only. That is also 2 square. So ultimately both are same, okay? So F will be 0 only, okay? It is also called equilibrium, okay? If the force on an object is 0, then the object is said to be in equilibrium. Equilibrium, okay? So if I derive it from the previous formula, you can see this is F1 square. You can write this part also, okay? In the previous question also you should suppose to write, okay? So it will be what 2 F1 F2 cos theta, na? But theta will be 180 degree this time because one force is along this, another force is along this. So the angle between them is this, okay? That is 180 degree. And remember, cos 180 degree actually minus 1. Okay, I have already given in the table. If you learn it, that is well, F1, F2, cos 180 value is minus 1 actually. So it will be what? It will be F1 square minus plus F2 square minus 2 F1, F2. Okay, but you know that A minus B whole square is what? It is nothing but A square plus B square minus 2AB. Okay, it is simply like this only. This formula also will be what? F1 minus F2 whole square. Okay. Now square root and the square will get cancelled. So ultimately what will left? F1 minus F2. That is why I am writing this. Okay. That is why. I hope you understood all. So answer will be what? Answer will be just none of the above only. Okay. Because zero option is not there. Understood?
Yes, sir.